A very good morning to one and all. I am Balaji Arambakam from ADH Department of Savita Engineering College, and today I am here to explain you about what is meant by QR decomposition. Here, QR decomposition splits a matrix A into two matrices: Q, an orthogonal matrix, or an upper triangular matrix. That is, A is equals to Q by C dot R. Understanding the code. Here's the first step: header and import. Import numpy as np. This imports numpy, a powerful library for numerical operations in Python. Second step: defining the function. Define QR decomposition of A. This defines a function QR decomposition that takes a matrix A as input. M comma n is equals to A dot shape, and then m is the number of rows and n is the number of columns in matrix A, and then q is equals to np dot zeros of m comma n. R is equals to np dot zeros of n comma n. Here q will store the orthonormal vectors and its shape is m by n. R will be the upper triangular matrix and its shape is n by n. And here's the third step: main loop, Gram-Schmidt process. I am explaining here the code. For j in range of n, v is equals to a of j. Iterating through each column j of matrix A, v is initialized to the jth column of A. Here's the inner loop, projection removal. For I in range of I, r of I comma j is equals to np dot of q of I comma a of j, where v is equals to v minus r of I comma j into q of I. For each previous vector, I is less than j, we project a of j onto q and q of I using the dot product. Subtract the projection from v to make it orthogonal to previous q vectors. And now normalize v to get the new vector. R of j comma j is equals to np dot lin algorithm dot norm of v. Q of j is equals to v divided by r of j comma j. Compute the length of norm of v. Normalize v to get a unit vector and store it in a column j of q. Return the result. Return q comma r. After all columns are processed, return the orthonormal matrix q and upper triangular matrix r. Here's the fifth step. A is equals to np dot array of all of input. Takes user input as a string, for example 1, 2 and 3, 4. Evaluates it into a Python list and converts it into a numpy array. Here's this sixth step. Calling the function and printing. Q comma r is equals to QR decomposition of A. Calls the decomposition function and stores results in Q and R. And now here's the final step of printing the results. Print f the Q matrix is Q and then print f the R matrix is R. Use the floor brackets and also double quotes and brackets as shown in the code. Prints the resulting matrices. For example, if you input 1, 1 and 1, minus 1, you will get Q is equals to 0.7071, 0.7071 and 0.7071 minus 0.7071, and now R is equals to 1.4142 and 0.1 and 0 and 1.4142. This means A is equals to Q divided by C dot R. And thank you.